One-way functions are one of those elusive concepts that you often hear or that people refer to. And they're certainly very important when it comes to modern cryptography. And they're pretty important to understanding blockchain as well. So because of that, let's walk through an illustration, a non-technical illustration of what one-way functions are. Let's consider Alice and Bob, as we often do when it comes to crypto. And let's further consider that they're both crossword enthusiasts, and they're pretty competitive with each other. Let's take a scenario where Alice is claiming to have solved the latest puzzle, and she's calling Bob and letting him know. Now, from Bob's perspective, they're talking over the phone. How does he know that she really did solve it? And at the same time, from Alice's point of view, she doesn't want to give it away, right? So what do? So Bob suggests, tell me the answer to 87. However, Alice feels pretty iffy because that might lead to additional clues and she might be helping him solve the puzzle as well. And she doesn't want to do that. She doesn't want to give it away. So the question is, how does Alice prove that she knows the solution without giving it away? And at first it seems that it's not possible. But this is a scenario where one-way functions can be very useful. So she proposes the following. Let's assume that the question or the answer to Bob's, can you tell me this field, or can you tell me this value, which was 87, what word is it? Let's assume the word is folio. So if they both have access to the most widely used English dictionary, which is the OED, and they both look up the definition for a word. In this case, this is something that Alice would do on her own. She would look up the definition of folio, and she would then take the first word in that definition, individual. She would then look up the definition for individual, and she would take the second word in that. So that would be here, human. She would then look up the definition for human and take the third word from that. She would then look up the definition for or, which is used to link alternatives, and take the fourth word on that. And then finally, just to go 5 levels deep, she would look up the definition of alternatives and choose the fifth word, which in this case is the word more. Now, Alice would take this word and share it with Bob, and she would tell Bob, this is the proof that I have solved the puzzle. And let's assume that 87 is one of those key components of the puzzle. And when you do solve it, or if you've solved it already, then you can go through this exercise, look up the word in this field, go through the sequence of finding the first word, look up the definition, then the second word, look up the definition, the third word, and so on. And if you truly have solved it, we both have the same dictionary, then you would arrive at the word more. So now let's look at this from the perspective of Bob. And let's assume that Bob really hasn't solved it. Could he cheat? Could he use the word more to be able to reverse this process and get to the solution or get to the word? So let's look at that. If he started to read the dictionary for definitions that had the word more, for example, the definition of ample, enough, or more, has more, but it's in the wrong place, right? It would have to be in the fifth place. So you can see already that simply finding a definition that had more on the fifth place would be very laborious. It would take a tremendous amount of work. Not only that, then he'd have to reverse that path. And for every path that he reversed, there would be a number of words that could match this. Many, potentially. And so you start to see this exponential amount of work that Bob would have to do in order to be able to reverse this. And then he's just getting to the one word. It would actually be much better for Bob to work at solving the puzzle. It would be less work than to try to cheat. So this is an example of a one-way function. It's pretty easy for Alice to do this and to give Bob the word, proving that she knew it. And once Bob can solve the puzzle, he would be able to verify whether Alice, her claim that she was faster, was valid or not. Now, an additional example for this would be, how do you just simply create an encrypted password using one-way functions so that Bob would not be able to guess it. And in this case, we'll consider that they both have access to Boston phone books and that Alice is using it to encrypt a word. And we'll take folio again. We're not looking at the crossword puzzle anymore. We're just looking at encrypting a word. And for every letter in the word, she would look up a last name starting with that letter, and she would take the phone number and create what you see below there. She's just basically adding up all of those phone numbers. Now, in order for Bob to reverse this, he'd have to go through the entire phone book, read all of the numbers, which for a major city like Boston, it would take a tremendous amount of time. And so once again, this is an illustration of a one-way function. Going in one direction is pretty easy. However, going the other direction is very, very expensive. And so this is something that is leveraged to secure a great deal of our communications. And this is the heart of a non-technical illustration of one-way functions.